And you are on.
All right, welcome everyone to the Melbourne AWS user group, meetup number 152. We would like to begin by acknowledging the traditional custodians of the land on which we meet today. In this building, we're on the lands of the Wurundjeri, Woiwurrung and Bunurong peoples of the Kulin Nation. We pay our respects to their elders, past, present and emerging, and we recognise their ongoing connection to this land. We extend that respect to Aboriginal and Torres Strait Islanders here or watching on the stream. We run these events to a code of conduct. The short version is up on the screen there. The shorter version is really just be nice to each other. The full code of conduct is on our website. If you feel uncomfortable in any way or there's something that you don't think is right, you can talk to myself or Rob, and there is an anonymous feedback form on that website as well. So, but we hope everyone enjoys themselves and has a safe event here. You can find us on the web, our website there. We have a user group or a presence on LinkedIn. We were on Mastodon, but the community, AWScommunity.social went away and we're sort of working on that. Or you can see us on YouTube. For those that are watching, it's where you're currently at. For those of us here, if you ever want to watch these live, you can go there. You can also watch the playbacks as well. All right, what we order for the night, have our introductions, which is what I'm doing now. We'll go through a What's New segment, talk about some of the new releases, features, updates over the last month. And then we'll break into two speakers. We may have to flip the order because Gokul unfortunately is being caught up in some train issues. So hopefully he will still make it. And then we'll also have Rinaldi. So if Gokul's not here in time, Rinaldi will go on first and may have a little surprise for people after his talk. And then finally, we have a marketplace section. How we run that is more of a who's hiring than who's looking for work. So if you or your company are looking for people, put your hand up and people can come and talk to you. We don't do it the other way because if you're sitting here and your boss may be watching on stream, that might be an interesting conversation to have tomorrow. And then we'll wrap everything up around about 8 o'clock. If you have any questions for tonight, obviously, if you're in the audience, as Rob said, please just wait until the end and we'll bring a microphone around so that people watching can hear what you've got to say. Otherwise, if you are watching, you can talk to us in the hashtag Melbourne channel in Slack, or if you're on YouTube, you can just put your question in the comments there. We can't run these events without sponsors. This is how we get the food, the venue, all those things, and we would like to especially welcome our gold sponsor, Mentel Group, our silver sponsor, Sivo, and our venue sponsor, NAB. So again, without them, these things are really difficult to put on. So I mentioned we have Slack. That's where you can find us, mel.awsug.org.au/Slack, and you'll get the info there. We have quite a few different channels on there. The volume varies a bit, but yeah, general, we have jobs channel there. Maybe if you're looking or especially if you have a job, you can post there. There is a volunteers channel if you'd like to sort of help us run these events. And probably one of the big ones, which thankfully we don't get to use too often anymore, AWS outages. So if something's going wrong in the world of AWS, usually that will fire up. And our announcements channel, a lot of these things that I'll be talking about in the What's New will appear up in that channel. All right, getting involved. If you would like to get more involved, there's a few ways that you can do that. Speakers are one of the really important things that we need. As we said, we can't do this without sponsors. We really can't do this without speakers. So if you have anything that you would like to present, this is a pretty friendly audience to do it with, and the organisers, we can help you out. If you've got some ideas, you're not sure, come and talk to us. We're happy to help, give advice. So it's a good place to come and cut your chops. We're also looking for sponsors. So if your company would like to sponsor the user group, come and talk to myself or Rob, and we can put you on to Matt, who's our treasurer. Fortunately, can't be here tonight, but do that. And also to volunteers, if you'd like to help out, just in sort of the general running, yeah, come talk to us, and we're always looking for people that can help out. So we're not the only game in town. There is a little thing coming up called reInvent in Las Vegas in December. If you ever get a chance to go, it is amazing. I think last year they had about 60,000 attendees, all sorts of tracks. It's a really great conference. So on that, is anyone in the audience going? Nice, yeah. It'll be fun. Definitely worth it if you can get there, but that's obviously big and far away. Much closer to home, we have a few things on. Women in Cloud have their next event on the 25th of September. It's at Mantel. So you can join them there and find out some, they usually have a lot of interesting talks there as well. So too, if you know any other females in your business that might be interested, pass on the message. And the AWS Melbourne Well Architected, they host that at the AWS offices. So their next one is 15th of October. And normally this is where the host will hand over to the next person, but everyone's had life or sickness, so you're stuck with me for this one. We have a few things that have come out to Melbourne in the last month. Reachability Analyzer, Managed Services Prometheus. So nothing really super groundbreaking, but again, more of these services that are starting to make Melbourne a more fully featured region and not just a backup. Sydney, got nothing new this month. As a proud Melburnian, I am happy to say that. Right, a couple of things from the database side of things. So RDS announcing cross-region and cross-account snapshot copy. So this one's nice if you're doing cross-region and cross-account for your DR. Previously it was a two-step. You either needed to copy cross-region and then cross-account, or vice versa. Now you can just go straight to a different account in a different region. So skip an extra step, make things a bit smoother and easier. Similar, OpenSearch has cross-account ingestion now, so you can take things in. I think I was reading up, but you need to use RAM to share that, but you can get ingestion from other accounts in your org. And another IPv6. There are a few things IPv6 that have been sort of extended or coming out in the last sort of month or so, and RDS proxy is one of those. Compute. So there's a few things there. A couple new EC2 instance types, R8 with sort of massive bandwidths and networking for everyone that uses all your Mac EC2 instances. I'm sure that's like almost next to no one. But M4 is now available. If you've got a use case for it, I'm sure that will make you happy. But yeah, there's some announcements to help you track your AMI usage better. So now you can find out who's actually using AMIs and if those AMIs are orphaned or not. So you don't have a lot of unused AMIs sitting around. And yeah, for your NVMe devices, there's a lot more metrics that are available to you now. Not a whole lot in the container space in the last month, but you now have Service Connect and support for cross-account workloads. Actually, that was the one that you needed. You need RAM for that one, but yep, that will let you work with workloads in other accounts without having to do a whole lot of extra networking, transit gateways and things. And yeah, machine learning. There's lots there, but mostly, nothing super new, other than there's a few of the MCP services that might be interesting, especially around your CloudTrail MCP server, and the ability to use your, there we go, actually, yeah, the excuse me, CLI support for remote MCP servers. So now if you're using MCP in your IDEs, you don't need to run them locally, you can access remote ones. Serverless, there's a few things there around step functions, again, IPv6, going out to more things, local stack integration in your VS Code, so that will help you if you're wanting to do local testing for your serverless apps there. So those things, a few things in security. So again, IPv6 for CloudFront, some extra TLS security policies, if you're going in depth with post-quantum support for there. AWS config supporting resource tags for IAM policies. So again, some extra monitoring and in depth if you're looking, have rules around that, makes that a bit easier. Storage, so yeah, S3 now supports conditional deletes. So you can do things like check if an object has been updated recently or not as to whether to delete it or if it's the same as when it first got deployed. And the malware protection for S3 has been drastically increased. So file sizes and the archive scanning limits have had quite significant increases to those. DevOps, a few extra things there. Your CloudWatch having your cross-account and cross-region log centralization. So that's really nice, especially for your security teams. They like to see things in one location. That makes that a whole lot easier. Budgets with custom time periods. So if you've got a project that, the example that they use is, say you've got a 3-month project that starts in the middle of a month and you just want to look at that budget for that time period, you can now start your budget across those that custom time period. Organisations providing account state information, so the states that were available to be seen. It's a bit more granular now, so you've got a bit more info on knowing when you provision an account, or even if you've got an existing one, what state that is. CDK Refactor is in preview. So you might have heard a few months ago they bought out refactoring for CloudFormation. So now they've extended that out to CDK. So if you've got a stack that you want to change, maybe split up or whatnot, it's now a lot easier to do that without having to really sort of tear down the stack and launch a new one with existing resources and things. So, actually, there's one. AWS user notifications has been pushed out quite heavily now, sort of replacing a lot of your AWS health events and things. Now you can centrally manage that. So that used to be on an account by account basis. So this is nice and handy to centralize the management of those user notifications. Other stuff. So if anyone's using AWS Outpost, then they've now got the new versions of the Outpost racks. So that's handy for anyone that's using those. You've got the ability to centrally manage the access to your AWS regions and local zones. So, when you start a new account and it's got the list of those new regions that you can include or not, that can now be centrally managed, and you don't need to do that account by account anymore. So a little bit of simplification. IPv6 again. They're really sort of pushing that out. And Direct Connect, new locations now in Auckland for the new Auckland region. Congratulations to our friends across the ditch. They have their own region. All right, and that is it from me. And thankfully, we have had our first speaker that's just rocked up just in time. All right, so Rob. All right, yep, if you wanna. Hi everyone. So we now have Gokul here, who's giving his talk on enhanced AWS cluster performance and cost optimization. Give Gokul a round of applause.
Can you see me? Cool. So, hi everyone, good evening. The topic that I'm going to present is enhance AWS EKS cluster performance and optimize cost. I've been working with AWS EKS cluster and Carpenter for the past 2 years, so I thought I'll do a presentation and share my learnings. So if someone else is on the same journey, they can sort of use this and it'll be helpful for their journey. Quick introduction about me. So I'm Gokul Venugopal. I have 14 years of software experience, specialized on migration, modernization, and platform engineering. I'm a lead consultant on CIBO Australia. So the plan today is, let's quickly look at what's AWS EKS, what are the different deployment options we have, what is Carpenter and what's so cool about it, and how do we migrate from existing solution to Carpenter if required. What is AWS Auto Mode? Compare the difference between Auto Mode and Carpenter, and quickly touch on monitoring and operations, and finally, summary and key takeaways. So I'll start with this. So AWS is really good at taking a complex open source project and packaging it as a managed service. So as a user, I can just use that solution as a service rather than struggling myself with setting it up and provisioning and maintaining infrastructure and whatnot. So the good examples are RDS, Kafka, Elastic Cache, OpenSearch, and AWS EKS. So before going to AWS EKS, I'll just talk about Kubernetes. So Kubernetes is something which got announced on 2014 by Google because it was used as one of their internal projects. Kubernetes is a container orchestration. It's used to manage and automate the deployment and scaling of a container solution. On 2015, Google donated the Kubernetes project to Linux Foundation, and from then it's been managed by the open source community. The cool thing about Kubernetes is it's portable and can be deployed anywhere. So it can be deployed on any of the cloud hyperscalers that we have currently, or it can be deployed on VMware or on-premise. So what, as I was saying before, what AWS has done is they took this open source project, bundled it up, and they launched it as AWS Kubernetes service. And in the process, they are managing the control plane and just letting the user to play around with the data plane so that as a user, I can just consume it as a service rather than worrying about setting it up from scratch. So if we look at the shared responsibility model, this is what it looks like. So AWS manages the EKS cluster control plane where they manage the EKS API server and ETC database and whatnot, and just provides the ability for the customers to manage or update anything on top of that. For example, cluster capabilities like auto-scaling, storage, or EC2 instances like patching, restart, monitoring, and whatnot, and application deployment on top of that. So this is we don't have access to the EKS cluster control plane, or as a user, I cannot see where it's running, but I'll be able to make any changes to the ones that are managed by the customer. So EKS has 4 different deployment options. The first option is unmanaged. So here AWS manages the control plane and lets user to manage the data plane, but this is of the options, this is the complex one. So because you'll have to have an auto-scaling group and EC2 instance on which you'll have to deploy all the Kubernetes components that are required to connect your server to the cluster and whatnot. So it actually requires a very high operational overhead unless you have a very specific requirement of needing this option. I wouldn't really recommend this because it's really difficult to run and operate this model. The second one, or the most widely used option, is the managed EKS cluster. Here again, AWS manages the control plane, but they provide access to the users to manage the data plane, and they do it via a solution called managed node groups. So you just deploy a managed node group and you configure it, and the managed node group works with the backend AWS services called auto-scaling group, and it manages the scaling up and scaling down. So this is a flexible option which provides the user more control, but also doesn't really require a lot of configurations from a user perspective to use this one. The third one is the Fargate mode. So this is a completely serverless solution. AWS manages both the control plane and the data plane, so you don't have any infrastructure to manage. But this is a slightly expensive option of the lot, and this comes with a lot of significant disadvantages, like you cannot deploy daemon set, or you cannot request more than 4 vCPUs per pod, or you can only, the maximum EBS storage that you can request is only 20 and things like that. So this is suitable for small workloads or bursty workloads or dev and test clusters, and this is not really recommended for a production grade. And I have not seen anybody using Fargate for production, but if you guys are using it, let me know. I'm keen to hear about it. The last and the last option or the latest one is EKS Auto Mode. Here AWS manages both control plane and the data plane, and there is no infrastructure to manage from a user perspective, but this option still uses the EC2 instances, so you will not have those limitations that you have in the Fargate, and this comes with a very low operational overhead, and this comes with also a lot of enhanced security features. Any questions before I go to the next slide? Go. So now let's talk about Carpenter and why it matters. So before talking about Carpenter, I'll just spend a minute on what was there before Carpenter, and the answer is cluster autoscaler. The cluster autoscaler is a very simple solution that basically helps to scale up and scale down the cluster worker nodes depending on the load, and it's tied to manage node groups. So once you deploy cluster autoscaler in the cluster, it works with the managed node groups, and it will look at your minimum and maximum configurations, and it will deploy more nodes to the cluster if there is an increase in load, or if there is a decrease in load, it will go ahead and remove the nodes from the cluster. And it's slightly slow when compared to Carpenter, because cluster autoscaler has to talk to autoscaling group, and then autoscaling group has to provision EC2 instance, and they provide confirmation back to the cluster autoscaler in case of scale up. And similarly for scale down, it has to follow the same path. So it's slightly slower. So this is what it will look like, let's say if you want to deploy 4 different containerized application, and you want the cluster autoscaler to deploy nodes for you. It will deploy node 1 on which you can host 2 container applications. It will still deploy a same copy of node 2 with the similar size and configuration, where the third containerized application can go and sit, but this node 2 has still a lot of unused capacity, which cluster autoscaler doesn't really care about. And let's say if there is a very large container application, or if you have a very special requirement of needing a GPU instance or whatnot, cluster autoscaler cannot really manage this, and that particular container application will still sit and think where it should go. On the other hand, Carpenter is nothing but a high performance cluster autoscaler, and it's an open source project, and that basically addresses these limitations that the cluster autoscaler has. So it is designed to handle the full flexibility of cloud. By that what I mean is you can specify a wide range of instance family and instance types to the Carpenter, and Carpenter is intelligent enough to choose the right instance type that it can provision when there is a requirement from a pod. And the code and the node provisioning is really quick, because Carpenter talks to AWS API directly rather than going via the autoscaling group. And the other cool feature is the real-time consolidation. For example, in this case, the node 2, though it has a lot of unused capacity, cluster autoscaler will not take any actions, but Carpenter will look at this and it will say, yep, there is a node in which I have a lot of unused capacity or not being utilized properly, so I can move this pod to a smaller node, so that 1, I save costs, and 2, it's properly being used. And the last and the really good information or really good feature is it works really with the Spot instances. So Spot instance, as you know, has 2 minutes notice before termination. Carpenter has a Spot interruption queue, where if there is a notice from the AWS, it will quickly move all the pods from the node that it's going to be terminated by AWS, and it will move all the pods to a different server, even without impacting or user being noticed about it. My face is hiding that, but ideally what I want to show is if we use Carpenter for the same requirement, this is what it might look like. So node 1 will be created by the Carpenter, in which it will host 2 pods, for example, Node 2 will be a smaller instance where it will be only one pod, and it will create a third large instance on which it can host the third or the last pod. So this is how EKS architecture with Carpenter will look like. So everything on the left-hand side is the AWS managed control plane on which the API server and the EDC database sits, and everything on the right-hand side will be hosted on the customer account. And Carpenter is kind of one of the EKS add-ons that is deployed on the EKS cluster. So if you have a EKS cluster, if you have a managed EKS cluster with cluster autoscaler, and if you want to migrate it to Carpenter, it's 3 easy steps. Step 1, you'll have to install the Carpenter as an add-on or using Helm. The only catch is you have to have a dedicated infrastructure to host the Carpenter controller node, because Carpenter cannot manage its own controller. Let's say if Carpenter decides to turn off all the instances, it'll also delete the Carpenter controller, then it will not have the intelligence to spin up a new instance if there is a requirement. So you'll have to make sure you keep the Carpenter controller separately. You can use Fargate, or you can use a separate managed node groups to host that. But installing Carpenter is like one-line command, or just click of a button to add it as an add-on. The second step is EKS node class. This is the instance level information where you can specify AMI, EBS, bootstrap, security group, and which subnet you want the instance to be deployed, and what is the instance role that you want to deploy, things like that. All these informations can be provided in form of a YAML. And the third step is node pool. Here you specify information about what are the different instance family and instance type and instance size that you want to use, what are the labels and taints that you want to configure for the instance, and do you want the instance to be spot or on demand, or do you want to use a combination of both, and what's the node consolidation configuration that you want to choose. For example, non-prod, you can let the Carpenter to do consolidation whenever it sees fit, but for production you can just choose a specific window in which it can do the consolidation. And what is the maximum CPU and memory limit that you want the Carpenter to go? That's the maximum ceiling. And this is what the architecture will look like on a very high level. Let's say on the left-hand side, you have an AWS EKS cluster with 2 different managed node groups, which is kind of creating few containers under service, fronted by a load balancer, and user is using that. And if you want to sort of deploy Carpenter, you will still have to have one small managed node group on which the Carpenter controller will be deployed. And after that, you don't have to create any more managed node groups, and Carpenter will deploy different instance types depending on the container requirements, and containers can be hosted on that. So the next is EKS auto mode. This is one of the deployment options, or the last one, which was introduced in the last reInvent. So in this option, AWS manages both the control plane and data plane. So I keep saying this word, control and data plane. Control plane is nothing but the brain of the Carpenter. Data plane is, I would say, the body of the Carpenter. This option reduces the operational overhead by sort of eliminating the need of configuring or managing the worker nodes, and it also does cool things like it automatically upgrades a cluster, it automatically patches if there is a requirement, it automatically does add a lot of add-on, and it automatically sort of refreshes the instances once every 21 days, because it makes sure any instance cannot go beyond 21 days. It just restarts the instance or creates a new instance, and if there is a new AMI released, it just inherits the new AMI, and it automatically upgrades the cluster based on that. The catch is it also has few limitations, and it's recently launched, and it has few restrictions, and one of the key thing is it only uses Bottle Rocket instance type, which is OS by Amazon for running containers in an optimized way. So if I now compare the shared responsibility model of EKS managed node group versus the EKS auto mode, here, as we were seeing before, AWS only manages up until the EKS cluster control plane. On the other hand side, AWS manages up until the EKS, cluster EC2 instances. By what I mean by this is, AWS will manage the instance lifecycle, operating system, patching, monitoring, health and repair, and will also manage all the auto-scaling and pod networking and storage class and everything. So as a user, you can just deploy this and deploy your application on top of it. So it literally took me 5 to 7 minutes to deploy the entire cluster and start deploying applications on the EKS auto mode. So this is what the EKS architecture with auto mode will look like. So if you compare this with the previous diagram that I was showing, here the Carpenter EKS auto mode also uses Carpenter behind the scene, but the only difference is the Carpenter in the EKS auto mode is managed by AWS, so we don't have access to it, and they manage all the provisioners and whatnot behind the scenes, and they manage the networking and storage and whatnot. As a user, we can just deploy load balancers and everything that we want to add to friend the service, and instances also will be deployed by the EKS auto mode depending on the pod requirements. So I'll just quickly compare what are the difference between auto mode and Carpenter. So let's say if you have a requirement to use a custom AMI, because auto mode doesn't let you to define an AMI or ID or whatnot, because it uses the latest AMI always provided by AWS. So if you have a requirement that you want to use a custom AMI, or if you want to use advanced networking like Calico or secondary CIDRs, or if you want to have a daemon set deployed, or if you are looking to monitor the Carpenter in a very detailed way, auto mode is not a really good option, because though it provides the ability to manage a lot of things behind the scenes, it also comes with a disadvantage. It doesn't let you to do a lot of things. On the other hand side, if you want a lot of control on your data plane, Carpenter is a really good option, but it also comes with few downsides where you will have to have a dedicated infrastructure on which you need to maintain the Carpenter controller, and there are, like, if you want to do a zero-touch upgrade and patching, or if you want to automatically refresh your worker nodes, it cannot be done by itself. You will have to still spend some time and energy and effort to make sure you do it if you're using the other option. So before going to the monitoring, I like this particular quote from Werner Vogel's CTO of Amazon a lot. Everything fails all the time, so we'll have to be prepared. The major shift in using an EKS auto mode or EKS managed mode with Carpenter is the introduction of Carpenter. Carpenter is a really stable solution adopted by a lot of industries and for production workloads, but still it's an open source solution. So it is really required that you need to still scrape the logs and build a decent or good monitoring solutions around Carpenter to make sure or understand what it does behind the scenes. There are a lot of out-of-the-box Grafana dashboards that are available for Carpenter monitoring. All you need to do is just to scrape the logs using, let's say, Prometheus, and forward the logs to Grafana, and it will provide you all those informations in a good way. Unlike having Carpenter managed by you, if you're using EKS auto mode, since Carpenter is managed by AWS, it doesn't let you to scrape logs. So in this case, you will have to rely on AWS CloudWatch. If not similar, it will provide good information so that you can monitor what Carpenter is doing to your cluster if you're using EKS auto mode. Proactive monitoring of Carpenter is really required to optimize cost and identify bottlenecks if there are any, so that you can continuously fine-tune the solution. And my key summary and takeaways is both EKS, managed EKS with Carpenter or EKS auto mode is good, powerful solution, and it comes with a lot of benefits. If you want to have control over your data plane, or if you have a requirement to use a customer's custom AMI, or if you have a requirement to use any specific agents or deploy daemon sets, or if you have a requirement to use custom networking, or if you want to have a granular control on patching and upgrades and cluster upgrades and whatnot, the best option is you can use managed EKS with Carpenter. If you want to have a reduced operational overhead, where you don't want to do patching and upgrades, and you want the cluster to take care of all those activities by itself, and if you don't need granular control on AMIs and custom networking and whatnot, then EKS auto mode would be the best option to choose. The other takeaway is, like, use spot instance where possible when using Carpenter, because it's really cost efficient. and you can save up to 90%. And the note is even AWS recommends not to use Spot instance for production, but if not production, go nuts and use Spot instance wherever possible. And use consolidation policies for underutilized or empty, or to consolidate underutilized or empty nodes for optimal infrastructure usage. This is one of the key benefits of the Carpenter, and just configure on what window you want this consolidation to happen in case of production. But if it's non-production, just you can set default consolidation window so that it can do consolidation whenever it sees if there is an opportunity to save something. And the last point, which I was reiterating in the previous slide, make sure you capture metrics and set up monitoring so that you can continuously monitor and you can sort of fine tune as you go ahead, because we've been using Carpenter for a couple of years and we had seen a few issues, and this monitoring really helped us to sort of fine tune, and now it's pretty stable. And we are also using Spot instance for all our non-production environments, which really saves a really good amount of money. And that's it. Any questions?
Yep. Does anyone have any questions?
I just have one question.
Sorry, just one. Bring the mic around.
I mean, on smaller scales, we use AWS Lambda, right? So, like, is there any sort of alternative in terms of using Carpenter in that space? You have any idea regarding that?
No, Carpenter works with Kubernetes. Carpenter is kind of a Kubernetes add-on, so it cannot work outside of the Kubernetes, cannot be used for Lambda. But if it's within Kubernetes environment, regardless of you're using Kubernetes on Google or Azure or Oracle Cloud or whatever it is, you can still add Kubernetes as an add-on to it.
Cool.
It's a very Kubernetes specific solution.
Anyone else? All right. Thank you so much, Gokul.
Thanks.
All right. Everyone give Gokul a round of applause. All right. And excuse me, Rinaldi. It's currently on mute. So maybe a little bit lower down.
I guess I'll.
All right, everyone. We're now ready for our next speaker, Rinaldi, and he is going to talk to you about policy-gated Bedrock blueprints and everything that entails. All right, Rinaldi, thank you.
Thank you. So, hello everyone. My name is Rinaldi, and today, I'll be talking about policy-gated Bedrock blueprint, a zero ETL, guardrail, multi-tenant Gen AI on AWS talk, basically. So, it's essentially going to be a very architecture-heavy talk. So, essentially just going to be centered around talking about particularly like how you center Bedrock within the overall architecture within a zero ETL multi-tenant architecture, essentially. So, we're going to go into it. But before we get started, I just want to show of hands, who here has already played around or is familiar with Amazon Bedrock by any chance? Yeah? 1, 2, 3. Okay, quite a good amount of people. Not too much, not to worry, pretty much. So if you're not too familiar with Bedrock itself, Bedrock is essentially, it's going to be crucial to this talk. So Bedrock essentially is Amazon's AWS's offering for generative AI solutions. They particularly have a platform within AWS, a service, a managed service basically, which allows you to access multiple models, multiple families of models, for instance, from like Metis Llama, Anthropic's Claude, all within one platform essentially. So for instance, you don't have to make an API call to each of these independent families essentially. You can pretty much just make a specific call directly to Bedrock and be able to make the specific calls based on that. So it's a unified solution essentially for being able to work with these particular models. So yeah, that's an important definition to get out of the way because a lot of what we're going to talk about is pretty much going to be quite centered around Bedrock as per the name of the talk as well. So to give a bit more background about myself, currently a software engineer, pretty much you can see my socials over there as well. And so I'm currently also an AWS community builder, have all 30 certifications from AWS. I'm also an instructor and author, one of which is the Using Amazon Bedrock book that was just published by Wiley. Also the host of a Serverless Sorcery podcast, international speaker as well at over 50 events and conferences. Also organized the Melbourne Python meetup, and yeah, pretty much in general, enjoy a lot, all things like AWS, open source, generative AI, and virtual reality. So why this particular blueprint? Well, oftentimes, if you're already working with an enterprise setting, you'll find that there is a lot of use cases for multi-tenant structures. You'll need to be able to understand how to be able to build multi-tenant architectures, and as part of that, you often need hard guardrails. You need to be able to understand who can use which models, tools, and also relevant KBs as well. And then we also have the specific ETL sprawl, which often slows specific teams too. And as part of that, you also may have 0 to ETL, which then look at cutting specific ops and also preserving the specific residency which you need, which is often crucial, especially when it comes to highly secure environments. And say if you're working for like a bank or financial institution, you often need this especially. And you also need to consider the need that safety and cost and audit, all of this need to be first class. Of course, given the regulations and the guardrails that are set by the institutions that you work with as well originally, because that's part of the regulations. So all of this needs to be really put into consideration and really considered carefully. And as part of the design principles, there are a few things to also mention here as well. So starting off with, we have policy first authorization. It's very important that we use specific policies in order to be able to put the relevant authorization accordingly. We have tenant isolation everywhere, which include like with tags, roles, data. This all is very important. And we also need to be able to put in place the relevant guardrails for being able to have the relevant specific safety and grounding when we work with the different kinds of data. And if you're familiar with Bedrock itself as well, Bedrock also has specific guardrails as well, which also pretty much constrains what you can actually put in place and what you can actually do in terms of the policies and in terms of the prompts that you put in place. And that's why with the nature of generative AI, it's a very important thing to ensure that what you're currently putting through is secured and also that you are preventing any malicious use of prompting essentially, for instance. And you also need to be able to have observability and budgets from day one to be easily observe what essentially these kinds of things need. So be able to observe specific metrics, be able to observe specific costs. We need to be able to ensure that this all is observed carefully. So a particular production kind of setup might look like this essentially. So I understand it might be a bit small, but pretty much to kind of like give a bit more of a show there. Essentially, we have the ops section, which has a bit of the budgets and usage essentially, which is where we keep track of things, maybe through Cost Explorer and such. That's where we keep track of relevant costs, relevant tracking for that. And we have X-Ray itself alongside with CloudWatch as well. Like this pretty much makes up the ops side of things, where we pretty much do a bit of the monitoring for our architecture. We then have the data plane itself, where we then store things such as the knowledge base, and that pretty much may derive from a number of different databases that we have on AWS. So as part of that, you can see over there, we have Aurora or RDS that is part of the databases, for instance. So our databases may derive knowledge from there, and we also have OpenSearch or vectors as well, which essentially is used from indexing essentially in terms of from the knowledge base itself. And of course, in terms of synchronization as well, we utilize like a S3 particularly, or lake formation accordingly as well. And on the right side, which you can see over there too, we have the orchestration side of things as well, where we use things such as like step functions that communicates as well with relevant lambdas as well, which is used essentially to make specific actions, execute specific actions, and ensure that we are executing specific steps that are on this architecture in place as well. We have the relevant client as well, which you can see over there at the top right, which essentially has the role of being able to have specific like users and tenants stored there, and pretty much have them interacting with things such as, like for instance, like your Slack when alerts are sent, interacting with your web app as well to be able to interact with the rest of the systems, and of course like pretty much like have the relevant API integrations as well. And of course we have the control plane on the rightmost side as well, which is where we have the IAM Auth0 like authentication or authorization essentially on the first end, and pretty much that would flow to using things such as like Amazon verified permissions essentially, which would use Cedar in this kind of sense scenario. And that would essentially then lead to having guardrails, particularly for Bedrock, which might communicate with step functions, which you can see would flow from step functions particularly. And from the Lambda itself, you would essentially see more interaction happen in terms of the SageMaker endpoint itself, which you may have, or it may also interact with Bedrock models themselves. So it really depends on, usually depends on like how you structure things, but this is just one example of one particular architecture that you might see being part of the place here. But yeah, this is pretty much an example of the high-level architecture that I'm trying to more or less like talk a bit more about on and share a bit more on. In terms of tenancy and identity, there are a key number of things that need to take into consideration. Starting out from IDP first. IDP first would essentially flow into going into like the IAM Identity Center, and pretty much we would essentially look at having like tenant scope roles in this kind of architecture. We would also have specific principal attributes, so things such as tenant ID, role, budgeteer, what's allowed. So these kind of things are usually captured as part of this particular tenancy as well. And we need to be able to tag specific requests as well with what tenant ID and request ID and model ID made the specific request as well. This allows us to be able to audit the systems better, and also, especially when we need to be able to look at which debug specific like metrics as well, and be able to look at specific auditing that is done for these systems, we're able to look at this at a more holistic way and also capture more data that would be necessary when we look at troubleshooting specific issues. So this is an example as well of having specific course controls as well with IAM, which is necessary, particularly in this kind of architecture. So you would have specific statements, particularly. This is just an illustration essentially of how that would look. We have a specific like invoke model, invoke model is a response stream. That's basically just a typical kind of like IAM, which basically just shows, yeah, what conditions specifically would it would partake in, what specific request tags or principal tags would be necessary as part of that. So I just wanted to pretty much like put a bit of illustration on that. And so now we go a bit into Amazon verified permissions, essentially, or Cedar in particular. So particularly with Amazon verified permissions, we would then look into putting the specific permissions on what is specifically allowed in terms of access, particularly in terms of the invocation, in terms of the knowledge base. So we can see, for instance, in here that we are defining a particular AVP, particularly gate in this sense, as a policy, which basically just permits that particular permission on making a specific action, permitting specific actions, be able to put it into specific like resources, essentially what's allowed, and yeah, when that would be allowed. So yeah, just pretty much like giving a bit of example over there as well. And that's when we then go into the zero ETL retrieval itself. So the preference oftentimes, and of course this depends on different architectures as well, but yeah, pretty much like the knowledge base was pretty much like sync from the S3, avoids heavy pipelines this way as well, which is pretty much like the whole purpose as well of having zero ETL in the first place, because we want to be able to have specific retrieval being done from zero ETL perspective. Having specific late formation as well for be able to have like row or column access particularly, and having app side SQL tool for RDS as well to be in place too. And there is also a big push as well oftentimes with zero ETL architectures to be able to have keeping buckets regional essentially for data residency, as I imagine a lot of financial institutions, banks, like a lot of these particular institutions have a lot of emphasis on that, and that's why zero ETL is a very important key element as part of considering that we need to be able to have this put in place essentially as part of these particular architectures. And just another example as well of a similar a particular setup as well with data sources as well that's being set up, what the type being S3, was specific like bucket ARN being taken into consideration as well, and also the embedding models that particularly like being used as well as part of that. And that would then lead us into talking a bit about the orchestration pattern, which then has includes step functions, the lambdas, and also the AVP as well, which would be necessary. So step functions itself, to more or less, what we would need from this is that we would need a bit of a transparent state machine for being able to have a bit of a chain of thought, and also to be able to execute relevant tooling that we would need as part of this architecture. So that's what we want to be able to use step functions for, and I'll show a bit more as well about the flow of how that would look in general in just a moment as well. And we would then use the Lambda to act as small adapters essentially. So this would look at being able to run specific things, for instance like SQL queries, be able to run specific ticket searches, like vector searches. In general helps to be able to execute that and be able to put through that essentially. And of course, running Amazon verified permissions as well as part of the checks as well before every single invocation, tool, query step, just to make sure that we are pretty much ensuring that they are under the specific guardrails that we are in, and we can also audit them accordingly. And that would essentially lead to talk a bit about how it would look in terms of step functions as well. So as you can see over there, this is just one example of a particular state function flow of how that would look like in this particular architecture. So we pretty much have a number of states over there, which start from like authorization, retrieving, guardrails, and generating. So this is the kind of flow that we want to get out of this more or less. We want to be able to have a specific like task, the authorization from AVP. We want to be able to then put into the query as part of like retrieving based on the query itself, and of course checking based on authorization as well. We want to be able to then put specific like guardrails as well, and pretty much generate what is necessary accordingly based on that using Amazon Bedrock. And in terms of the Lambda itself, this is just one example of an adapter that could be essentially used. So particularly in this case, we're basically kind of like running a simple SQL query, which basically like select title, summary, docs, and of course this is very adaptable as well based on the use case that you have for the specific adapter as well. And the point of this more or less is to just show a simple example of how one such adapter would look like, although this can clearly be adapted to different use cases and different kinds of, well, institutions essentially, and of course like relevant knowledge bases that each institution has as well. And that will essentially just retrieve accordingly, execute the statement, and return the relevant rows as well. From a guardrails configuration, this is just one example, particularly on how a particular configuration would look like. So things like essentially like hate as the type, and pretty much just making sure that the specific guardrails are put in place. And in terms of a prompting and tool contract side of things, we need to be able to ensure that the specific system prompt that we set through also pretty much enforces specific policy as well. So for instance, we say things like only use the specific allowed tools, ground answers, and make sure that you cite specific sources which you have used from the knowledge base as part of this as well, to ensure that it really tries to ground the answers a bit more in terms of facts and in terms of what you actually have within the knowledge bases, rather than trying to hallucinate, which is one problem that a lot of knowledge bases, a lot of models often have when you work with generative AI. And you would then look at having specific tool schemas as well, return a specific JSON, and having the storing the specific prompt version as well, and of course also the decision accordingly in the logs as well, should there be any audits necessary. If you're familiar with a lot of platforms these days, a lot of platforms are starting to integrate a lot of generative AI capabilities now, and one of the things that you often notice is that there is often a bit of a button which basically, if it's kind of like, if you see basically that it's some kind of chatbot, or if you're able to pretty much generate something from it, there's often a bit of an option that says like report this a result maybe, and pretty much based on that, that often goes back to pretty much like an institution, and pretty much you're able to check on the back end to be able to see, okay, what was the prompt that was submitted, what was the result, is this actually correct, and from there you are able to flag it, and from there you're also able to accordingly make iterative changes as well based on that too. And there's a bit of a serverless variant to this as well. So we can see over there, for instance, that if we look at it from a serverless variant, pretty much you would have like a bit of an API gateway or application load balance accordingly, and that would flow into step functions, and accordingly we can see how that pretty much would flow in terms of essentially in terms of like Lambda tools, Bedrock, knowledge bases. So essentially it can be done both, essentially in a serverless way as well, alongside also being provisioned as well, say like if you're calling things from an EC2 or something like that as well. So this is just showing how it would look like, at least in a neater fashion from a serverless perspective. And in terms of containerization as well, oftentimes ECS or EKS can also be used for long-running tools, particularly heavy dependencies, sidecars. You would be essentially looking at using containerization as part of this as well. And you might be looking as well at having specific like SageMaker endpoints for specialized inference or fine-tuning being done too. Of course, Amazon Bedrock has its advantages pretty much, but oftentimes for the more specialized machine learning or AI capabilities, oftentimes people turn to SageMaker, and that's particularly when you look at provisioning specific endpoints, particularly for that. And you would also look at keeping AVP, as a very permissions, gating as well on endpoint ID accordingly, and also metering separately as well based on that too. And I'd just like to touch a bit more as well on the data residency and isolation, because it's a big motivator as well for being able to have the specific talk in the first place about multi-tenancy, because essentially oftentimes how a lot of the best practice approach goes within these kinds of scenarios, especially when you look at the residency requirements, is that there is the need for the per tenant S3, having an S3 essentially on the relevant tenant, each relevant tenant. Of course, also putting in place specific policies as well, like server-side encryption for KMS, blocking public access as well as part of like the buckets too. On the other hand, you would also look at having specific permissions as well if you were to utilize lake formation, where you would also specifically utilize like VPC endpoints and such. And of course, you would also look at having no cross-region PII replication. Now, from an observability perspective, you would also then look at having specific metrics, traces, and logs captured accordingly, as mentioned just now as well. So you would be looking at recording specific tokens, cost, tenants as well, and this all would be recorded in particular events that you would ingest. And this is just an example of how this would essentially be put through. So yeah, you would essentially put through a specific like tenants, you would put the tokens, the specific cost as well, and all this you would pretty much be able to debug things and also have this for iterative improvement as well, so that you can see, okay, how can I best optimize my queries, not only maybe in terms of the security perspective, but also in terms of the cost that you're putting through. And from a cost controls and budgets perspective, of course, you could be looking at different budget tiers as well. Maybe it's like token per hour, daily cap, via, of course, like the pre-flight AVP or throttling accordingly. And you would look at right-sizing specific models as well, look at differences as well between like embedding versus generating, and of course like streaming only as well, like when necessary too. Being able to cache specific RAG chunks as well and responses, ensuring that you also have a bit of a short time to live as well where necessary too, and using specific cost and using cost and usage reports particularly for being able to keep track of specific costs, budgeting, and making sure that you're on top of your spending in terms of generative AI. Because oftentimes when you work with specific models, you work with an enterprise and then people start sending you big queries, pretty much oftentimes it gets overrun very easily. So it's a very important thing to quickly ensure that you're up to speed with keeping track of this. And particularly for as well like Athena as well for per ton chargeback. So the flow would look more or less similar like this, essentially, if you were to integrate, for instance, like with something like Slack. So oftentimes, where this all goes is that you pretty much have a specific architecture, then you would want notifications and be able to log certain things basically to be done like via Slack. So this is just an example of how that would be integrated with Slack as well. So you would have the user particularly like ask, for instance, like let's summarize a particular query essentially for like our results from Q3 that would go to the Slack app that would then post the payload to the API, through the API, pretty much through referencing tenant ID. Of course, like API will return reply, but it first then goes into the step functions where you then start to execution that would then go into verified permissions where you then talk about the, where it then basically checks the specific like model KB tokens. It gives the permission from verified permissions that retrieves and generates, sends it over from step functions to knowledge base, returns specific chunks. It invokes with guardrails towards Bedrock, and particularly it then returns the completion plus the citations as we talked about just now as well. And that would then return a specific result and request ID, and that return the reply to the Slack app, which is where we then are able to see the specific results as well that's being put through. So as part of a security review checklist, this is more or less a very brief checklist that I would essentially say would be important. So having IAM boundaries, tag enforcement, having deny by default within Amazon verified permissions, having specific guardrails, content, and grounding as well accordingly, enabled in prod, having specific keys as well in Secret Manager to ensure that you are storing them in the right place, ensuring that they are secure, and having specific rotation as well, being triggered for on, and of course, securing via network, via VPC endpoints as well, and logging all the specific data for access as well. So for shipping this week, I would say it's, pretty much like you could look at shipping like the per 10 S3, KB, guardrails, having specific like Amazon Verified Permission Store, base header policies, having specific like skeleton for state functions being set up, and having like one Lambda tool, having the specific like embedding of the metric format metrics as well, alongside with the budget alarm being set for if there's any issues as well with the budget, because like I said, it gets overrun very easily. And pretty much integrating with Slack for a bit of a POC end to end. So that's pretty much like how you would look at doing it, and pretty much something that could be set up as a skeleton to kind of like start off with. Oftentimes, a lot of these architectures you start up from very bare bones. You set up kind of like an MVP, a very minimal architecture to start off with, and pretty much from there you see the first queries being submitted to it. You see how people are interacting with it, and then from there, iteratively develop it and build on it, essentially. And to give a bit of a demo, this is more or less a local kind of example, basically, that I provisioned. This is basically just kind of like a bit of a local, I would say kind of like a local host implementation that I tried more or less, but yeah, the main key point here is just to show the implementation basically of guardrails and how that would look like in terms of how it would retrieve data. So yeah, particularly for instance, like you would look at getting the specific like basically like summary basically. So yeah, basically like how many tokens are taken up, what's the cost. But on the other hand, if you basically try unallowed model, then basically it would just return like denied by policy, model not allowed. So that would be how it looks like on the front end side of things, essentially. And what are the key takeaways? Well, to start off with, policy first Gen AI. Having specific IAM and verified permissions is very important to be able to ensure that we have the specific gating for models, tools, KBs, and spend. I think one of the things that we often forget when we work with generative AI is that we get so hyped in what generative AI can do that we actually don't spend too much time talking about the dangers of generative AI and also what it means towards the organization. And that's what a lot of organizations right now are trying to look at more at. And I know that a lot of the banks here, for instance, a lot of them are investing in generative AI. A lot of them are, well, a lot of financial institutions, big risk like institutions as well, are looking into this as well. So it's a very important thing for a lot of institutions, and yeah, pretty much it's become more important than ever to take a look at. And yeah, essentially having zero ETL wins as well, having bedrock knowledge bases, lake formation cuts ops as well with that, while being able to preserve the specific data residency. Safe by default, having specific bedrock guardrails helps to be able to achieve this. So you would have specific content alongside grounding to be able to wrap every generation step with the help of that. And you would essentially want to be able to ensure that all the prompts and everything that goes through the architecture would be accountable and observable. So you would be able to need to be able to emit tenant scope metrics, traces, logs, and costs for review and chargeback. And from a blueprint perspective as well, you would want to be able to have same pattern scales across serverless, containers, SageMaker specialization. So all of this, you particularly would want to get this particular blueprint up, and that's what I'm trying to pretty much convey as well from this as well, to have like a repeatable blueprint that more or less can be put into practice. Well, starting off from like a staging environment first, of course, because these kind of things take a bit of time to experiment first internally before you release into production, but yeah, pretty much that's a very important thing. And yeah, so pretty much you can also learn more as well from, essentially like a book of mine, which essentially is coming out in November as well, which I'm actually doing a bit of a giveaway after this as well. So yeah, today I'll be giving away actually 3 of the copies of the books. It's not out yet. It's going to be out in November, but I'll pretty much be in touch basically after a bit of a short quiz basically to kind of more or less see who gets basically those like 3 books basically. So yeah, pretty much that is all from me. I think we can do questions first probably, yeah?
Yep. Thanks, Rinaldi. Does anyone have any questions? Yep, I'll bring the mic over.
So I'm very new to this Bedrock service, but as a platform team, do you have any recommendations? Are there any config rules or service control policies, resource policies that we as a platform team can put in place so that our builders that are building these sorts of solutions do follow some of these best practices?
I think there's a number of layers that you can put in place. I would say that from an IAM perspective first, I would say, like, I'll answer from an AWS perspective, I would say. Like, from an IAM perspective, you can definitely put some specific policies in regards to governing the guardrail specifically for the policies first, I would say. Like, that's the first thing, like what users can and cannot do, including like, like for invocation for such, basically. I think the first step pretty much would be getting users across what would be necessary as part of the IAM first, because that would be like the basic thing. But aside from that, of course you have like the implementation through guardrails themselves as well. You pretty much would be able to, when you kind of like dive a bit deeper into kind of like Bedrock, you then pretty much would look at specifying specific guardrails. So I think like that's the easiest way that you pretty much would be able to also govern the use of Bedrock particularly as well, like what prompts can and cannot be submitted basically to a specific, I would say kind of like a specific use case basically. So yeah, and a lot of banks are particularly starting to use that as well. For instance, like okay, like if you are like a chat bot basically that is supposed to give advice on, let's say kind of like, well not advice, but like you're supposed to kind of like provide like customer service support, you're not basically supposed to provide like advice basically on like people's financial transactions. And that's one of the easiest things that pretty much like you could just do from guardrails. Like you would just accordingly like put specific like instructions like, yeah, like don't, yeah, like you would pretty much like put as like a denied topic basically. So those are pretty much like two main key things that I would keep in mind at least. There's obviously much more pretty much that you could put, especially if you, for instance, like are using, for instance, like AWS organizations and such. But yeah, those two would be like the main ones that I would look into first.
Cool.
Thank you.
Any other questions? Yep.
I mean, just a follow-up question on that. I mean, even I'm new to this space. So, I mean, in terms of guardrails, just wanted to know, like, are there any sort of user prompts that we can put in to sort of, you know, filter out things, or is there any sort of universal framework or protocol followed across organizations in terms of guardrails? So yeah, I just wanted to know on that part. The other question is, you showed about log monitorings and the analysis on that, right? So is there any sort of different tool within Bedrock to check out the logs, monitor that, to see the amount of tokens being used? Yeah.
Yep. So starting out with, yeah, pretty much for, in regards to like how particularly it would be logged essentially, I would say that you are able to keep track of things through CloudWatch mainly. So pretty much like have the specific metrics through CloudWatch. A lot of the metrics particularly that you do pretty much like see as far as like invocations and such, like you pretty much would be able to keep track and centralize through CloudWatch. That's, I feel like, the easiest way as well. Like you keep track of that alongside your other metrics. Same with cost. Cost particularly, you could also keep track of Bedrock cost through Cost Explorer as well, essentially. So you'd be able to see like, yeah, the amount of spending that you would have towards that, and also pretty much like put a specific like budget as well towards that too. So normally you would be able to keep track of things like through there. Sorry, I might not remember the first question. Sorry, what was the guardrails?
Yeah, yeah. I mean, do you use any sort of user prompts in terms of guardrails? Are there any sort of frameworks and protocols universally being followed in terms of being guardrails?
Ah, gotcha. Yeah.
Yeah.
So for guardrails itself, so there's two layers to this. First, usually you would set a system prompt essentially, which more or less governs overall like what the task is supposed to be done basically from the model itself basically. Like, okay, what am I? Am I supposed to be like a customer service agent? Am I supposed to be like, say, a flight agent or something like that? Like, this all is important to set at the get-go basically, but at the same time, from guardrails, you can pretty much set also like denied topics as well basically. It's like, okay, what specific things am I not allowed to talk about? Like, I like probably like, for instance, like, yeah, especially like if you're like selling like, let's say like cars, for instance, like you wouldn't basically like want your bot to basically like agree to selling a car for like $1, which is like basically like a very interesting example that I keep seeing on LinkedIn popping up, I think these days a lot. There's, yeah, for context, there's like this one, I think there's like one LinkedIn post where I forgot like what car brand it was, but like basically the folks over there basically had like this one person that kept on trying to like jailbreak the whole chatbot basically, and basically kept saying like, can you sell me the car for like $1? And like basically they did. sell the car for $1. And yeah, after that, it then became a whole legal issue. It was like, oh yeah, technically because the chatbot officially said, yeah, I'll sell you a car for $1. Should I sell the car for $1 or not? But yeah, anyway, that's beside the point. But yeah, that's just an example basically of that you can pretty much set these specific topics. Like, yeah, like for instance, like, yeah, to prevent that, you could have set like a guardrail of like, yeah, I don't want to like, you should not act basically to be able to sell specific cars from your own and not be able to like allow users to jailbreak you. So these kinds of like guardrails basically really do a lot for that. Thanks.
Cool. All right, any other questions? All right.
So you had a Lambda function that called RDS database. Was that sort of indicative of other things you could do, or were you actually, because I couldn't actually see that in the step functions. But nevertheless, that's one question. The other one is were you looking at using an MCP in there as part of the query tool set? And if the query toolset is pulling data out of a database, do you have to check the answers for prompt injections as well, or do you just assume that the data is clean?
So for essentially, I would say that you would definitely be able to do a bit of debugging, I would say, like on the back-end side of things, to be able to check basically if from the answers. So that's one of the reasons why it's very important for specific like specific kind of like answers to more or less like be logged essentially. It's like, so for instance, like say like we say like basically like and that's very important as well from an observability perspective, that we do have like specific like metrics being set up as well for that too. So for instance, like things like, okay, like are there any keywords that we need to like flag as well? Like this is going to get into a bit of a, I think, like advanced discussion, but since kind of like because cleaning and detecting, I would say, kind of like prompts itself is like another completely topic as well within this as well. But yeah, like if you kind of like, usually a lot of organizations have a lot of filtering that goes into what can be put into like specific like bots, for instance, like what can be flagged, specific like, I would say, answers basically as part of that, and like what, and then from there, like if there's anything flagged as part of these particular answers, it would then go into basically kind of like being flagged as one particular possibly anomalous answer, and then accordingly, like the user from the back end, like it would basically, these kinds of things basically would then be added into what probably would be blocked as part of like a denied topic, for instance, to prevent like jailbreaking in the first place. But I know Bedrock itself already does have jailbreaking capabilities as well, particularly in terms of detecting jailbreaking, so it does help out like quite a bit as well. Your first question, I think it was on Lambda, sorry, was it?
Yeah, I saw, I didn't quite follow exactly where the Lambda
yeah. For the Lambda was pretty much like meant to more or less be kind of like a, is meant to kind of like more or less just show that you can pretty much like put other things into like place. But yeah, that particular one that was shown basically was meant to more or less just show a bit of a retrieval from, yeah, pretty much like RDS. But yeah, pretty much you can put anything there. So it's just like a kind of like a sample step basically. Yeah.
Cool. All right. Given the timing that Rinaldi has his giveaway, we'll stop questions there. I'm sure he'll be happy to talk to you afterwards. But yeah, Rinaldi, your giveaway.
Thanks. So as part of this giveaway, we're just going to, we need to, I see that I'm off the internet. I just need to get on. Now, where is that? Okay. Okay, so we're just going to play a very simple quiz. If you're familiar with, anyone here familiar with Kahoot? If you're familiar with Kahoot, this is a very simple, similar things to Kahoot, basically. But yeah, we're pretty much going to play a very quick quiz. I know it's nearly at 8, so we're just going to keep this quick, just 5 questions. So yeah, we're pretty much just going to do a very quick one. So,
All right, so get your phones out, people.
Yep, please get your phones out, and yeah, we'll pretty much just pretty much go into that, go into the specific that specific website like playloveluke.com and just enter that game ID. Okay. Yep.
All right. A few more seconds. All right, we're good to go.
Cool. Yeah, let's get started then. All right, so first question, what's the main benefit of using a zero ETL pattern with Bedrock multi-basis? It's A, no need to write SQL queries, B, faster model accuracy, C, easy cross-region sharing, or D, lower operations overhead. Okay, that's like 9 people got it. Yep, so looks like SV is taking the lead there. Let's go to the next question. As a reminder, top 3 will pretty much get the book as part of the giveaway. All right, so which of the following model providers was available in Amazon Bedrock when it first became generally available? A, Cohere, B, Quen, C, Mistral, and D, Luma AI. So yep, the answer is Cohere. And also
Even
the
I
only
didn't get
two.
that one.
And yeah, SV is still taking the lead. Looks of it. Oh, yeah. All right. So what does applying Bedrock guardrails achieve in a multi-tenant Gen AI system? A, it blocks unsafe or ungrounded responses. B, it auto-generates IAM policies. C, it changes embedding for faster responses. And D, it reduces API costs. All right. Looks like most of us got it right. All right,
Ooh,
looks
we
like-
have a lead change.
Yeah, looks like John is taking the lead now. Oh, SV is taking the lead. Yep.
Yep. This is-
All right. So the policy gated Bedrock blueprint, which AWS service provides fine-grained runtime organizational models, tools, and knowledge bases. Let's just skip that.
Ooh, that was a bit of a split there.
Yep, last question. All right, when was Amazon Bedrock first made generally available to the public? So, not when it was in beta, but it was when it was GA. So April 2022, September 2023, November 2023, or February 2024. Yep, so September 2023. It's like, yep, so yeah, looks like, let's see
Yep,
the
TD,
top 3.
John, and
Outside 5.
outside 5.
Very
All right.
nice. Could we get a hands up for these folks?
Who are those 3?
All right, John.
John?
Are you all in the room, or we got one in the room?
All right, who's outside 5 on DD?
Yep, DD.
DD, outside 5.
Oh, it could be an online person, maybe.
Yeah.
Rob's just
Yeah,
checking.
outside 5 is online.
Oh,
Yeah, nice.
gotcha.
Oh, that's cool.
All
That's
right.
one of the good things about the Kahoot. You don't have to be here.
Sounds
So-
good. For John and DD, outside 5, probably.
We'll figure that one out.
Yeah.
We'll sort it out and get back to you with their details.
Sounds good. Yeah. John and DD, feel free to come see me after this, and we'll figure out how to get the book to you in November.
Cool.
Thanks.
Thank
I'll
you,
hand it back.
Rinaldi.
Thank you.
All right, we now have our marketplace segment. Is anybody hiring at the moment? All right, that unfortunately seems. Oh, yeah, go cool.
Hello everyone again. So at CIVA we are looking for principal migration engineers. If you are specialized in AWS and migration, talk to me. Thank you.
Yep, and Siva are one of our sponsors, so yeah, feel free if you're looking for something in that range, go talk to GoCool. And on that note, we will give a thanks to our sponsors again, our gold sponsor Mantel Group, our silver sponsor Sivo, who are currently hiring, and a special thanks to NAB for this venue. All right, and we will be back here next month. As always, the last Wednesday of the month, so October 29th for our next one. We would love to see you there, and thank you everyone for coming.